Today we're going to start our class, and the best way to start a class on astronomy is to just go outside and take a look at the night sky, see some of the objects we're going to talk about in their actual natural habitat, so to speak. There's far too many of us to fit in any one place, and we're scattered too widely over the globe, but through the wonders of technology, I'm going to invite you in a minute to do a virtual night sky tour with me, and I encourage all of you to take either a virtual tour, or even better if you can, to go outside and take a look up at the sky. Familiarity with the night sky is not the main object of this class, but it's a very pleasant side effect, and I hope you'll enjoy it. So, without further ado, let me invite you to join me virtually in a field outside of Athens, Greece for definiteness, and we'll look up and see some of what we can see in the sky. Welcome to our observatory. We've chosen to locate ourselves in the outskirts of Athens, Greece. It is November 27th at 9 p.m. and when our software is simulating the sky, and we're looking to the south. We have a very broad field of view of a full 180 degrees, so we can see all the way from the eastern horizon to our left to the western horizon to our right. But because of the light pollution of a nearby city, we see very few stars in the sky. This might be what you can see, or it's certainly what I can see when I step outdoors. But the brightest stars in the sky are bright enough to shine against the glow, so we might see over here in the east Betelgeuse and Rigel and perhaps Capella and Aldebaran. And over here on the western horizon we'd see three very bright stars, Vega over here, Altair down there, and Deneb over here, and these make up what is normally called the summer triangle. Let's step a little farther away from the city where more stars are visible and try to get a better look. There, that's better. With software, it's much easier to turn off light pollution than it is in real life, and now we see the same view of the sky as it must have appeared before the invention of electric lights. And let's take a look and name some of the objects we see. Over here to the east, we saw the two bright stars, Betelgeuse and Rigel, which are now seen to be, part of the famous constellation of Orion the Hunter. There's his chest and his legs, his belt from which hangs his dagger, his club or bow over here, his outstretched arm. He even has a head up there, and that would be Orion the Hunter. And Aldebaran will be part of Taurus the Bull. There's his head and his body and his long outstretched horns. Looking farther to the right, we can identify some other famous groups. This W-shaped object is associated with Cassiopeia, the vain queen, and not far from her, this great square of Pegasus, and from the great square Pegasus towards Cassiopeia, these two streaming lines of stars associated to Andromeda, Cassiopeia's daughter. And up here, Vega, the bright star we saw in the western sky, is part, in fact, of Orpheo's lyre. This is the constellation Lyra. And finally, my favorite constellation, we talked about Deneb over here, and Deneb is just the tail of Cygnus the swan. There's his tail, and Suther his heart, and a long swan neck that ends at Alberio his head, and then his pretty swept back swan wings. You can certainly see a swan. There are many other constellations, but I don't have time to show them all. Let's allow the software to do that for us. Here I've let the software designate for us the most famous of the constellations and the brightest stars that comprise the shape or the asterism of the constellation. And we see Orion the Hunter and Taurus the Bull and Pegasus the Flying Horse and so on, as well as many others. And what we recognize is that many of them have their origin in Greek mythology, at least in the Northern Hemisphere. The reason for this is, and the point I'm trying to make with this image, is that if you showed this picture without the helpful blue lines to someone who lived in Athens thousands of years ago, I don't know, the philosopher Aristotle, he would not only recognize the stars, he would name the constellations, and he'd use the same names that we use, because the pattern of the sky, as Aristotle saw it on a fall day in Athens 2,000 years ago, would be extraordinarily similar, essentially identical to what we see today, absent light pollution. There is this beautiful permanence in the sky. The stars that we see today are essentially the same as they've always been. And this is something that has made astronomy one of the oldest sciences, it's also something we can use to establish a geography of the sky, so that if I want to describe, or if an astronomer wants to describe viewing an object that lies right here, even if it's not part of the asterism of Orion, he would say the star lies in the constellation Orion. Astronomers have formalized this by, in recent memory, actually dividing the sky into 88 regions in the northern hemisphere. They're associated to ancient Greek constellations for the most part. And so now we precisely can distinguish a star that lies in the constellation Orion from a nearby star that lies in Taurus. And when we talk about stars lying in one constellation or the other, I will be referring to this treaty that divides the sky into the 88 constellations. The point that this again is trying to remind us of is that a star that is in Orion now will be in Orion a century hence. And so there's this geography that we set up, and we can identify positions in the sky. Removing for a moment all the distracting lines that the software was drawing, let's take a closer look at some of the objects we're seeing and try to pay attention again to what we're seeing. So we see large numbers of stars. We notice that they were different colors. Some of them are more reddish or orangish or yellow, and some are blue. The colors of stars are in themselves an interesting topic. We'll talk about that. The distribution of stars is interesting. If you look, you'll see that there are less stars here or here than there are along this region of the sky, this stripe through the sky. And in fact, if we look closely, we'll see that even in between the stars, the sky here is brighter than elsewhere. This is, of course, the famous stripe of the Milky Way. We'll want to take a close look at that. Here's what part of the Milky Way looks when you take a slightly long exposure photograph. The exposure brings out many, many stars, and we see that this bright stripe in the sky that I called the Milky Way has a lot more structure. It's not just a white stripe. There are these darker areas and brighter areas, different colors, lots of stars. We'll take a close look at that and try to understand what the Milky Way is. There are some other objects visible in the sky that will justify a closer look of the form that Aristotle would not have been able to take advantage of. If we look at Orion here, and if we look at the stars, the three stars that form the dagger dangling from Orion's belt, then certainly the middle one, it's pretty clear, it does not really look right. There's something fuzzy about that star. We'll take out a telescope and get a closer look at that. The slightly fuzzy, suspicious star in the center of Orion's dagger that we mentioned turns out, in a moderate telescope, to be a lot more interesting than you'd think. In fact, all of this stuff, all of these stars, all of this nebulous, scattered light, blue and pink, these darker regions, all of this is what our eye sees as a slightly fuzzy star. And understanding what is going on in the Orion Nebula is going to be something that'll be very exciting for us. Slightly farther south over here, just past Taurus, and in the constellation Taurus in particular, is this weird collection of stars, a whole bunch of stars clustered together very close. The collection of 7 bright stars in the constellation Taurus, traditionally called the Pleiades, in some cultures the 7 sisters, different names for this obvious bright collection. Here are the 7 bright stars. We see that there are many others near them, just not bright enough for us to see. And even again, as in Orion, we see that there is this nebulous stuff. There's this blue shiny stuff that is not a star that is producing light. So some of the light we see is not coming from the stars at all. And if we look at this collection of stars, then perhaps it's worth looking just below Pegasus over here. If we looked very closely, there would be a faint and slightly fuzzy object, probably better seen with a telescope than the naked eye. In a moderate telescope, the slightly faint fuzzy object in the constellation Pegasus that I mentioned turns out to be this beautiful globular cluster called M13. Again, we see many, many, many stars, far more in fact than in the Pleiades. We also see that they're all dimmer. The stars in the Pleiades were bright like this. These are dimmer objects. And they also appear to be very much more tightly clustered. In the constellation of Andromeda up here, in between Pegasus and Cassiopeia, if we look around here, there's another one of those fuzzy objects, suspiciously not quite star-like. If you magnify it a little bit and collect light for a long time and process carefully, turns out to be this beautiful, richly structured object, the Great Spiral Galaxy in Andromeda. I should point out that the fuzziness that we see is only the brightest central part of this. This object itself is about 5 times the size of the full moon in the sky. It's very large and very, very faint and requires careful image processing and light collection to get all this structure out. But nevertheless, our eyes were not misleading us. There's something interesting there, certainly worth investigating. Farther to the west, remember the bright star Vega in the constellation Lyra. If we look over here in Lyra, we'll see with a telescope a faint fuzzy object. The slightly fuzzy object in the constellation Lyra that we saw with a moderate telescope turns out to be this beautiful ring-shaped nebulous light. Lots of fun colors in this, and understanding what this ring structure is will be a lot of fun for us as we go along. And finally, we'll take a close look at this moderately bright star Albireo, the head of Cygnus the Swan. When you look at it more closely, it turns out to be not one but 2 stars of differing brightnesses. There's a bright and a dimmer star, and of completely different colors. One of these is orange. The other is described by various people as being either purple or blue or green. But certainly these 2 stars are very obviously different colors. Understanding why stars come in different colors, what these 2 have to do with each other, will be another topic we'll spend some time on. Hope you enjoyed the little preview of all the things that we can see that poor Aristotle could not, because he did not have telescopes. Let's go back to what it is that Aristotle did see. I've made a big deal of the fact that the sky is unchanging, but in a sense I was cheating. All the time we've been talking, it's still 9 p.m. in our simulation. I'm not going to let time move at a somewhat accelerated pace, and then we will see that the sky is not in fact unchanging. Things move. Orion is clearly moving from low in the eastern horizon to high in the south, and eventually will set in the west. But things maintain their shape. The motion is not random. The motion is rigid. Of course, pretty soon the sun will rise, and we might as well stop observing. So let's collect ourselves after a good hot cup of strong Greek coffee and summarize what it is we've learned. Back from our night under the stars, hopefully all energized and excited to understand all the things that we've looked at, let's see what it is that I was trying to make clear from these observations. We saw that we see many, many stars. We could see as many as 3,000 at a time on a clear night. And we saw that we named the groupings by ancient Greek names because the pattern that we see in the sky is unchanging. We also watched the sky move, but we noticed that the motion was a rigid motion. Betelgeuse and Rigel remain in the same relative position. They're both in Orion, in the same relative position throughout the motion of the sky, and in fact have been in that position since humans started observing them. So we can set up a geography of the sky. We can declare some part of the sky to be Orion and another part of the sky to be Cygnus, and this is a meaningful thing despite or throughout the motion of the sky. That said, the sky moves, everything rises in the east and sets in the west, so what you see in the sky at any given time is not a constant time, and our job for the rest of this week is going to be to understand and mathematically describe, at some level of precision, this motion and this permanence, and how we can predict what it is that we will see looking up from Athens at 9 p.m. in what direction in the sky.